Students, today we are discussing about how to find out significant figures. There are certain rules to find out significant figures. First rule, all non-zero digits are significant. For example, 123, 1, 2, 3. All are non-zero digits, therefore they are significant figures. Total 3 significant figures are there. So digits 1 to 9 are significant figures. Secondly, we want to talk about zeros. Zeros are 3 types. First one is trapped zeros. Trapped zero means zero in between two non-zero digits. These trapped zeros are always significant. For example, 105. 1 and 5 are non-zero digits, they are already significant. This 5 is a trapped zero in between 1 and 5. Therefore, that zero also significant. Total 3 significant figures. Secondly, leading zeros. Leading zero means zeros left to the first non-zero digits. They never be significant. Let us take an example 0.0095. Here, these zeros, that is 0 left to the first non-zero digit. First non-zero digit is 9. This 9 and 5 are significant. These zeros are never be significant. Therefore, leading zeros never be significant. Total 2 significant figures are there. Third one is trailing zeros. Trailing zero means zeros right to the non-zero digits. These two types, that is, if a data which contains a decimal point, trailing zeros are significant. If a data which does not contain decimal point, trailing zeros never be significant. So take an example for trailing zeros. Example 500. We can take it 500.0. These all zeros are trailing zeros which contains decimal point. Data contain decimal point. Therefore, they are significant. 1, 2, 3, 4 and 5. 5 is non-zero digit. Therefore, they are also significant. Total 5 significant figures are there. Next, take 500 as the example, which does not contain any decimal point. Therefore, this 5 is a non-zero digit and trailing zeros are not significant because data does not contain any decimal point. Total 1 significant figures are there. So this data which contains decimal point and not decimal point. Therefore, trailing zero which does not contain decimal point are not significant figures. Listen the third one. If a data which contains 10 to the power 56.5 into 10 raised to 3. Here 5, 6 and 5. They are non-zero digits. They are significant. But 10 raised to 3 is not significant. Just avoid that. So total number of significant figure is 5, 6, 5, 3. 3 significant figures are there in this data. Total 3 significant figures are there. We can check some examples. First one 85.967, just an example. Here look these all. Calculate how many number of significant figures are there. So here all are non-zero digits, therefore total number of significant figure is 5. Here 2, 6, 5 are significant. 0 trapped 0, therefore 4 significant figure. 8, 7 are significant. These zeros are leading zeros, therefore not significant. Total 2 significant figures are there. Here 5, 6, 2, 7, 2 and 7. And this 0 trapped zeros, significant. But this 0 trailing 0 which contains a decimal point, therefore decimal points are there, therefore 7. Calculation based on significant figures. Calculation based on significant figures. First, addition and subtraction. Add 12.36 plus 1.276. 13.636. But by adding or subtracting, rule is the answer should contain least number of decimal point in a given data. The answer should contain least number of decimal point as in given data. So here first 12.36, 3 and 6, 2 decimal point. Here 276, 3 decimal point. So total 362 decimal, that is the least number of decimal point. So we can just draw a line like this. So how many number of union figures are there? 1, 3 and 6. Next letter is 3. But look the next digit after 3, that is 6. 6 means above 5. If a digit is above 5, preceding number is increased by 1. Therefore answer is 13.64. Another example, 4.328 plus 13 plus 5.45. Just add this. Answer is 22.778. So look, which one is the least number of decimal point? That is 13, which does not contain any decimal point. Draw a line like this. So draw. Answer is 22 or 23. Look the next digit, that is 7, above 5. Therefore 2 increased by 3. Answer is 23. Next, multiplication and division. Rule is the answer should contain least number of significant figure as in given data. Take an example, 1.23 into 5.6. Answer is 6.888. So look, least number of significant figure. 1.23 contains 3 significant figure, 5.6 2 significant figure. Least significant figure is 2. So for answer, count from here 6 and 8. 2 significant figures are there. But this digit is above 5. Therefore 6.8 becomes 6.9. So answer is 6.9 contains 2 significant figures. Next example, 56 into 28. Answer is 1568. So look, 56 2 significant figure, 28 2 significant figure. Answer should contain 2 significant figure. So 1 and 5, 2 significant figure. Look, this 6. Therefore 5 increased by 1 unit. 1600. 1600 is the answer. Take another example. Our question is rounding off into 3 significant figure. 16.156 into 3 significant figure. Rounding off to 3 significant figure. So total 5 significant figures are there. Here 16.1. Look at the next number 5. So 16 point, next digit is. So during rounding off, if a digit is above 5, preceding number increased by 1 unit. Preceding number means number just before that number. So if it is below 5, no change for the preceding number. Here 1 is the preceding number. So it is equal to 5. Equal to 5, 2 rules are there. If the preceding number is odd and even, it is equal to 5. 1 is odd number. If it is odd, that increased by 1 unit. And if it is even, no change for that number. It is 1, therefore it is odd, increased by 1 unit, and answer is 16.2. So answer is 16.2. Take next one, 16.256, rounding off into 3 significant figure. 16.2. 2 is even number and it is equal to 5. No change for that number. So answer is 16.2. 16.2 is that. So that's all about the significant figure. Thank you for listening me. Thank you.